Hi, I'm Nathan McMahon. I'm a product management with Avi Networks, and we'll run through a little bit of a quick demo of what Avi is, what Avi does, and try to answer some questions around how Avi is able to help with, I have to read it, network-based real-time analytics and auto-scaling of applications. So we'll go into a little bit about some of the use cases, some of the challenges of a couple of customer use cases. I'll talk about one, which is one of our customers, Mazzetti. And then we'll also talk about another customer, which is
Macy's. My name is Melvin. We'll walk through some use cases that we're currently engaged with them on, and kind of give some insight into the retail world. I guess is what you'll see.
Yeah, so a little bit about the customer use cases and a little bit about the challenges in the industry, and then what Avi's doing to help solve some of these challenges. And we'll go through a little bit of PowerPoint, a little bit of a demo as well, so you'll get to see some of this in real time, assuming our VPN connection stays up, which I don't know if it will here in the basement, but we'll find out. So the first use case that I've got is a customer called Mazzetti. So what Mazzetti is one of our customers that about a year ago came to us with some interesting challenges. They're a large architectural firm, so they've got a lot of engineers and architects throughout the country, and they've got about roughly 13 or so physical locations where they have their users, their architects, and all the people that go along with this. And these are their end users. They're all connecting back into a central ERP application. At the end of the month, they all have to submit everything from finance to their diagrams of what it is they're building. All of their normal day-to-day kind of operations all get sent in the last day of the month, and the site is absolutely crawling. And for the most part, people are used to this. This is just the way the world is. And this company is pretty aggressive, growing pretty quickly, and so they made an acquisition. They acquired another architectural company based out of Seattle. And when they did this, after the first month, the people in Seattle freaked out and complained and said, "This is horrible, this is awful, this is completely unacceptable. It's just so slow that this is not going to work." And so the customer, the IT director, said, "Yeah, we know it's bad because it always is. But is it really bad, or is it that these guys are just never? Is it worse for them, or is it just that they're not used to how bad it could be?" And he wanted to get some little more data about this, like what is the problem, where is the problem, and is there anything I can do about this problem? So what they've got is a number of these different locations, roughly about 13 or so locations. They bring on a new site, they bring on Seattle, have the Seattle clients, and all of these guys are now connecting back into their data center. So this is all going across, they've got VPN connections connecting all these various discrete locations back into their central data center. So this is all going over a private network, not over a public internet. So it's all 10 class addresses, et cetera. And clients are saying, "Hey, site's slow." At the application tier, then it's a 3-tier application. The client that comes across the internet, or intranet in their case, they connect to the front-end web server, which hits the app server, which then hits the database in the back. And your typical 3-tier architecture. So the customer's then saying, "Yeah, okay, it's slow, but where in this whole process is it really slowing down? Can you help us break this down into something a little more meaningful?" So just kind of a quick detour here into who and what Avi Networks is. So Avi Networks was formed a number of years ago with the intent to really shake up the application delivery space. When I started in this industry back in the late 90s, it was just about basic load balancing. And can I spam TCP SYN packets across a couple of servers, call it good, go home. Application delivery kind of migrated a bit a little away from ASICs into more CPU-based as it moved into application delivery, where you terminate TCP, you terminate the HTTP or the protocol, and really have a much richer understanding of the application. But since then, since about roughly 2004 in this case, application delivery has been very, very stagnant. And so what Avi has done is Avi's really trying to reinvigorate this market by taking advantage of a lot of additional capabilities and technologies in things like Hadoop and big data analytics, architectures like SDN, virtualization, and understanding, identifying applications and users, taking all of this knowledge and feeding it back into the application delivery process to come up with something that's a little more intelligent, a little more meaningful, more actionable, more scalable and elastic as well. So Avi's really trying to turn the application delivery space around by having it be a little more cloud-based, a little more next-gen. And we'll go and show off a couple of examples of this as well. So to kind of understand how Avi plays in this space, typically what you had in the past with like a load balancer or an application delivery or these kinds of network type devices. These network devices will typically be an active standby pair. And what Avi's doing is taking away that active standby pair hardware model, putting it into as a software-based application delivery fabric or network services. You'll also hear this referred to as. As a network service, we're simply software-based, and we've done a couple of things. One of which is we've separated out the control plane from the data plane, meaning our load balancers are going to sit in the data plane, do the load balancing, do a lot of all the hardcore network processing. But from an end user experience, you're going to interact with simply a controller, a single UI, a single controller. You may have load balancers distributed throughout your network, multiple data centers, etc., but you still have one viewpoint, one central point to manage. So it's all very central architecture. And this distributed architecture like this is where you're seeing a lot of the hyperscale websites going to. If that's going to be a Facebook or a Google, etc., that's where you're seeing the same architectural approach. So what you get in this case is that our load balancer, our service engine, it's a micro load balancer. It's about a 200 megabyte file, in this case OVA file, that we can deploy anywhere we need, wherever the applications may exist. So we can reside next to and adjacent to the applications. And in this case, if we have additional traffic, additional clients come in, we can simply fire up more load balancers or increase the scope or the size of the load balancers dynamically on the fly. So we can go from 1 megabit to 1 gigabit to 10, 20, 30. We can simply scale up or we can scale down based upon the load or the end user requirements. So this allows us to be very dynamic, very flexible, and very elastic. And that capability is really important as you start trying to understand, right now today I'm turning on this feature and it requires this much capacity. Well, if you turn on feature X, Y, and Z, the capacity is going to grow or potentially shrink. So you need that ability to be dynamic, be able to match to the application's challenges as well. If the application gets more traffic, then the application delivery infrastructure needs to be able to respond accordingly without any additional configurations, etc. So some of the other things that Avi's done that's really shaking up the market is that typically today you've got a lot of visibility and monitoring tools. And that's going to be something like, that's not cool. So a number of different tools for monitoring applications, monitoring the network, and this could be APMs, NPMs, log analyzers, various analytics engines. And so you have them on one end, and what those are able to do is those are able to look at, here's the health of various aspects in your network and your infrastructure. And on the other extreme, then you have an application delivery infrastructure. And the application delivery controllers that you may have today are in line with traffic, they're full proxy. However, they don't have any view into the network itself. They're running completely blind. So what Avi's done is extend the capabilities of what an application delivery controller can do by extending that so that it touches into the visibility and monitoring and analytics. And this is very important and very powerful because this gives us the ability, now that we understand what the application's health is, when we understand what the end user experience is, we understand that if we make this configuration change, did it make things better or did it make things worse? And without that feedback, you have no idea when you're making a configuration change, did turning on this TCP Nagel's algorithm, did that make things better or not? The only way you find out is if the phone rings and somebody calls and complains and says, wow, your site's down. And that's very much a 1990s era way of doing business. So that's what Avi's looking to do, is really turn this on its head, provide that feedback so that you can both triage problems, but also so that you understand and visibly are able to see, yes, this fixed my problems. So Avi's in line with application traffic as a full application proxy. So when we're doing our load balancing decision making, we can take advantage of things like understanding what the client information is, what the server health is, what the application's doing, that interaction. That information, that metadata, can be sent up to our controller. The controller can analyze this out of band so it's not slowing anything down, and then use this information to feed back into the load balancing algorithm, to feed back into the entire system. So if we decide that something like the applications are in, let's say they're getting a lot more traffic and the experience of the end users is slowing down, what actionable changes should we make to help resolve this issue? So taking this back a bit to the use case of Mazzetti, was that this turned out that this was, as we sat in line with the traffic, we found out pretty quickly that users from Seattle were indeed complaining. Their experience was tremendously worse than everyone else's. And what it turned out was that they had a routing problem. Users from Seattle were actually going via VPN over to another location and then it VPN back into the Denver data center. So they were taking extra hops where everyone else is going direct. They were ended up bouncing around because they made some misconfigurations. So we didn't necessarily detect the misconfigurations in the routing, but what we detected is that client's network time was more than double any other user at any other location. And so we're able to say, this is something is definitely wrong with the network. They were definitely seeing some issue here and that these guys are having a problem. We need to go and track down and have you figure out why these guys are bouncing through and their time is taking more than twice X. But another problem that was interesting is that they also had an application problem. And this is part of what took them so much effort to understand what the problem was. And on their database in the back end, we're load balancing the web tier, the app tier, and sitting in front of the database, we found that on the disk 3 of their database server, was the I/O was completely saturated, and that was what was melting down, causing very, very long application response times. So the application was slow for everybody due to this application problem, and it was especially slow and compounded because of a network problem that was happening for this particular users coming from Seattle. So understanding that where these issues may be occurring and when they may be occurring is something that's very valuable to be able to say, what should we do, how could we fix this, and doing this type of triaging. So this is my first use case of Mazzetti. And I'll turn this over now to Melvin.
All right, thank you, Nathan. All right, hi, my name is Melvin. I'm actually with Macy's.com working in the merchant group. And I think we connected with Avi about last year at VMworld. And we were looking at a particular issue on our side, primarily from the CI, continuous integration perspective. And as we started to explore more, we started building out use cases to see where we can go with Avi Network. So I think we're all traditional. We have data centers across the US, and usual activity for retail is you start planning for that, Black Friday, Cyber Monday, right? And so traditionally we take last year's data, we guess how many servers we should get ready for the holidays, and then we start spinning them up throughout the various time zones, as the day progressed, and then even to Cyber Monday. That planning effort, I guess, is great if if that's your only time of the year, right? That's Black Friday to recover your whole year's loss. But as companies such as Macy's and others start to get more aggressive, we can't just rely everything on Black Friday. I think most people now get an email, right? There's a special flash sale. Traditional planning from an IT infrastructure can be very difficult when our merchants go, hey, let's do a sale tomorrow, and let's just do it, right? There's no planning other than we assume we have everything set up to scale up the infrastructure because we did it during the holidays, so we should be able to do it year round. So flash sales is a great example. Many of our competitors do it, and just the overall, that peak time, right, of getting traffic through can be very burdening on a system. Just the amount of traffic going through, making purchase orders, and then double checking with your inventory, right? Because you have to cancel the sale if you're out of stock, right? We don't usually do rain checks for the most part, but that short period of burst, right? Usually, I think most companies now do a one-day sale for the whole day. I know I've started seeing people trying to do it like within an hour time frame. So you really need to be able to scale up. And so using Avi's load balancer is a great solution, especially working with the CI teams and DevOps teams who've created scripts that we can then leverage in these situations where we detect an increased spike. We can actually use proven chef recipes that would deploy the server and application and connect to the application. And then when we see those spikes go down, we take it back, right? The other interesting use case, and I think many people probably do this now, right, is you actually buy online, and you start to notice, it's not just Amazon anymore that's returning, getting your package to you in 2 days. If you buy from Macy's, we actually go and find a store nearby you to see if we actually have it in stock. All right, so the shortest time I've gotten something delivered to me was a day. It was in Walnut Creek. I live up in Vallejo. The system, I went online, made the purchase, it routed all the traffic, found out it was in the store in Walnut Creek, and basically the store itself fulfilled it and sent it out. Imagine now when you're in different areas across the country, now your stores are actually becoming the shipping locations, and so now they get increased traffic and orders, they're now fulfilling it, and we have to scale, again, if we have if we have those flash sales popping through. Additionally, right, the technology to get us through there. Best Buy, I think, was probably one of the early ones to do this. You buy online, get it in the store. Macy's has introduced it last year, where we actually we started out with a couple stores, and I think now we're close to almost every store has the ability to, we can tell you whether or not it's available online. The normal process would be, the stores, as people go into the store, start making purchases. If there's special sales going on, inventory is going to come in very fast. It's going to go to some centralized database that we have, and at some point we have to process that data so we can actually reflect it on our online site. So we can tell you whether or not you can buy it very close to real time. That data throughput can actually be very tremendous, especially when we have marketing strategies of targeted locations with particular items for sale, such as Southern California. I believe they're more, or sorry, Miami, I know, for example, sells a little bit more white, right, for their Miami Beach events. So for the actual group that I'm part of, we actually do a lot of the processing. So where we engaged that with Avi, we noticed we were having a problem over the years. We were starting to get more data, more processed from the stores, processing from online. We're heading internationally. Our normal flow would be we get information, we send it to a single server, and then eventually we process it into a database. Oops, why did that? But as we're getting more and more traffic from the stores, more coming from mainframe systems, warehouse, fulfillment, we actually notice there's a slowness of data processing. We can't produce it, we can't keep up with the demand. We have spikes. Merchants tend to do things at the end of their day, which is most of our merchants on the East Coast. So 2 or 3 o'clock in the afternoon over here on the West Coast, we'll get notifications going, holy crap, your server's capacity, your network is slow, everything's down. So what we're trying to engage through is to actually start getting a little bit more smart in analyzing our data flow, but that was actually very difficult. So with Avi, we're able to start setting up a load balancer between the points between the stores coming into our data warehouse, and actually be able to start spinning up at those certain times of the day, especially as we get close to holiday and 3 or 4 other events throughout the year where we know historically we have problems, but now, right, my usual joke at working at Macy's, the one-day sale is almost every week. You can't get away with it. The world is very fast in consumer consumption. Let's see, why is this? This is getting a bit too slow. All right. So overall, this is our ideal situation, able to start adjusting to traffic, getting in, processing and keeping that information, and then eventually send it up to the website to keep things in sync. The true is reverse. People start buying more online. We have to also then start figuring out where we can fulfill from the different locations. So where we find this solution very useful, obviously in production, but in order for even get there, we're finding using Avi as our load balancer in our CI infrastructure lets us do some really great planning, do a lot of simulations, figure out where our pain points are, because right now in those organizations with DevOps, we have scripts that deploy servers and applications, and this has been a great time for us to get ready for certain moves, such as holiday or July 4th. I think is our next big one for us. But from a DevOps or CI, we can actually start testing out all the different simulations and then make adjustments to figure out what our workload is going to look like and be able to ensure that we're scaled and consume. So finally, we're going very fast. We're actually now looking at putting Avi into our CI as part of our solution so that we mimic exactly production at all times. With information that we can get from the network in production, we can actually make sure we simulate the exact same thing in our test environments, our performance environments. We will now have a better way of correlating that information and then be able to see that we get the same results and make the appropriate predictions. So I guess I'll hand it back to you, but I'll just leave it at that.
Okay. Thank you, Melvin. All right. Now for the really cool part of the demonstration. We'll actually go and do some of this. So right now I'm logging into one of our controllers and assuming that our VPN is happy with me. So when I'm logged into one of my controllers, I've got a number of applications. I've got a number of load balancers behind the scenes. So this is all running within VMware. This could be any kind of a virtualized environment. In this example here, though, the controller is running on VMware itself as a virtual machine. Our service engines, which are micro load balancers, they are also running as virtual machines within VMware as well. And I've got a number of applications here, and this one's green. It's got a health score of 99, so it's pretty happy. I've got some other ones here that are not quite as happy. This one it's yellow, it's got a health score of 64. This means my application is up and it's working. However, there is some risk to it that an administrator may want to go and take a look at and prioritize and understand what's going on with this. So right now this one has a performance score of 72, which means from an end user experience, this site's relatively either slow or it's getting a lot of errors. So we may want to go and explore and understand what's going on with this. I've also got a resource penalty here, and that could be CPU, disk, memory, or some other resource limitation, either with Avi itself, or that could be with your back-end servers and infrastructure. And then anomaly penalties, if you're seeing normal traffic patterns, a nice pretty sine wave, day to day, week to week, and then it just drops off to zero, something's not quite right there. We may want to explore that. And a security penalty could be if you're getting hit with a DOS attack, or if you've misconfigured SSL, so the site works, but it's very much insecure and it's vulnerable to a heartbleed or something like this. We want to be able to flag that and highlight that. So I'll drop down into one of these applications. We very cleverly name our applications. This one is our anomaly virtual service. And you can see first off from an end user experience here, right now on average, clients that are connecting over our intranet from our load generator are taking about 1 millisecond to connect over the internet to Avi. From Avi to the server is picking up a connection very quickly as well, about a millisecond. The server takes about 50 milliseconds to generate content. Transfer the content back is very quick, it's very small objects. So an end user experience on average right now is about 57 milliseconds, which is pretty good. But you can see periodically here, I get these big spikes in traffic. And when that happens, I can tell you that, yes, things definitely got worse. End user experience went from 50-some milliseconds to 580 milliseconds. However, these numbers didn't change at all. What changed is the application is now taking significantly longer to generate that content. So I know I need to look on the back end there with those servers to understand what's going on with these servers. Why are they suddenly need a whole lot of extra time to do the same job? So what it means is that if some client calls in and says the site's slow, I don't need to get the network team, the app team, the virtualization teams all into the war room, have them point fingers at each other for a couple of hours. I already know where the problem is. There's definitely a problem, and that's where it's at. I'll drop into another application here. This one's called Broken Link. And this one also, it's got a lower health score. Performance is pretty bad here. So my end user experience is actually, it's decent. It's on average about 148 milliseconds. It's okay. But let's see if I can shrink my screen a little bit so you can see this here. Under requests here, we see that there's about 26% of all requests are resulting in errors. So you can see the green versus the red. So we're giving back a lot of errors are getting fed back to the users. And this could be application errors, this could be network errors, etc. But I definitely need to go and explore why am I sending back so many errors. On the right here, you can see that I'm load balancing, distributing traffic across 4 pools. This is content switching. So the content comes in, the request comes in, and we're distributing to different pools of servers based upon who the client is, what the content is they're requesting. So without even too much effort, I can tell you that one of these pools is yellow and the others are all green. So that probably tells me where to go and look. And I can go and drill further into this pool and understand a little bit more about its health. It's got a couple of servers. One of these servers is got a health score of 100. It's happy. The other server, not so happy. So without even doing any further reconnaissance, I can tell you that I'm probably getting a low health score because of this particular server. And we can continue to drill down a little further. But instead what I'll do is I'll go back to my virtual service view. And if I go and drill in, I can drill into, be very specific, not just saying at a macro level, users are getting 100 millisecond response times. I can drill down into every HTTP request or TCP connection. So because we're an application delivery controller, we're a load balancer, we're in line with traffic, I see all this information. So we're recording anything that we consider interesting, anomalous, or any errors, so that you have a complete history here so that you can come back in and say, if that user called in and complained and said the site's slow, if that user logged into the application, I can say, what's your username? I can type it into the search field, and I can go and immediately search for their interaction with the site, and I can tell you what their experience was. I can take any one of these particular logs, expand on it, and say, someone from Korea using Windows 7, using Firefox, logged in at this time. They were getting, I can't read it, icon something .gif or .png, and they got a 404 back from the server. So I can go and explore further about that and say, a lot of these seem to be 404s. Anything that's in blue here, I can have it be a filter, and I'll click on that and filter down by 404s. So right now I'm looking at the past 6 hours. I've had 28,000 404 messages sent back to clients, which is quite a few. And I can go and take a look at things like the URL path to see what they were. And almost all of them, about 99% of them, are from these two images. And the rest of these are all PHP attacks because this particular site is on the public internet and you get script kiddies coming through here on an hourly basis, which actually is a lot of fun because you can set up rules to go and do things with them, redirect them to competitors or whatever you want. But I can also go and look at something like server IP addresses. So I'm sending out all these 404s. 99.98% of all these 404s are coming from this one server. So I may want to go and explore and find out why this server is missing a couple of these images. This seems to be the source of why I'm giving back why we're having some problems here and why we've got a lower health score. Different ways we can look at this. So we can go and expand and explore on this, and we can look at something like if the response time, so this is client round trip time is greater than 50 milliseconds, I can go and mouse over that and say if it's greater than 53 milliseconds, and that filters it down to what exact approximate times. And I can go and find, and let's say in the case of the Mazzetti use case that I talked about earlier, what they did is that they actually said anyone coming from 10.1.x or this IP network, we created a group for them and called that group the Seattle group. Anyone coming from 10.2, they're coming from San Francisco. And they went through and they created, gave us their IP address ranges for each of their remote offices, put them into groups. And so they were simply able to go and type in here and just type in a particular custom filter, and in their case, Seattle. And they were able to go and do a comparison of users coming from Seattle, what was their end user experience versus users coming from San Francisco. And so by doing this, they're able to do a comparative analysis, which was very, very powerful for them. It's something they did not have access to before. So that makes it very powerful and very easy for you to do. Kind of think of it more of like a Google search for your application and network traffic. You can just start typing something in. If you're lazy like me, you don't even type, just start clicking your way through to happiness. It's all HTML5. And if client browser equals, it auto filters it for me, and I'll just say it's mobile Safari. That's 27% of my clients here. And so breaks it down to here's all the requests coming from Safari. So if I want to look and understand, maybe if it's something like you're getting a JavaScript error, et cetera, I can tell you that, yeah, anybody coming from IE6, they seem to be timing out on my JavaScript pages. So it gives you a very, very powerful ability to analyze the application traffic, the end user experience with this traffic, and also how that traffic behaves over the network, which this is what's very important, is that now that I've got this information, as I'm making changes, I get to see, did that change make things better or make things worse? So really quickly, I'll go and I'll drop into another application here. This one, this application is, I'll change it from the past 6 hours to showing you real time. So this application we cleverly call Scale Out Virtual Service. So this application right now is pushing about 370 megs of traffic or so. This is running on one load balancer, which is using one vCPU core, so about 1/16 of a server. So it's very, very limited. It's doing SSL termination and a number of other functions. And right now, it's the health score is a little bit lower. We're getting a resource penalty. And you can click through View Insights, and it'll tell you that you're running out of CPU on this on your load balancer. You need to scale out. We have this one set up as manual, but you can have it be manual or automatic. In this case, it's manual, so you can see this. So what I'll do is I'll click on Scale Out, and what this will do is this, I'll be running from one load balancer. I'll now be distributing the traffic across two load balancers. So our controller is going to go and fire up another load balancer if it needs to. Again, it's about a 200 meg OVA file, which is pretty quick. It goes and scales out to another, creates another one, gets its IP networking up, and in a few seconds this should be up and live. And I've now got two load balancers handling the traffic. Now, if you're set up in an automated mode, this would have happened without any interaction. There's also little icons down here that says, hey, there's a couple of a system event and a config event that happened. So if I click on the config event, it says an action scale out was just executed by a user admin. I can go and see more info about that. So when you see this big change in traffic behavior, or traffic pattern, you can say, hey, what just caused that? And I can go back and say, that's what caused that. Somebody made this change. And so now I can see I went from handling about 370 megs of traffic I'm now pushing 600 and something, about double the traffic or whatever my load generator can send. Which is great that I can automatically scale out Avi's ADC resources. Same thing can be done then on the back end if you want to set up some flags to be able to say, if the applications themselves are running out of capacity, I want to be able to scale them up as well and have a golden image of my web server and just go fire up 2 or 3 or 4 more of my web servers as traffic increases to them if they become the bottleneck. And most importantly as well is that now that I made this change, I can also go back to my end user timing here and say previously I was averaging about 10 something milliseconds of end user experience. That is now almost half of what it was now. So now it's about 4.5, 5 milliseconds. So what I can see is that I've got validation that making this configuration change resulted in a dramatically better experience for the end users, which is very important to say, was this a good thing to do? Was this not a good thing to do? And without that kind of information, without that visibility, you're simply making changes completely blind without knowing if this is solving problems or not solving problems. So with Avi, this gives you, it's all software. It's very quick and seamless to download and install this in VMware or virtualized environments like this. And we work with a number of different virtualization platforms. It's something that's dynamically scalable, has all the features that you'd expect for an application delivery, such as SSL and persistence and security, acceleration, etc. But beyond that, then it has that ability to be interoperate with next generation architectures. It has the ability to hook into a lot of things like your Chef, Puppet, Ansible, and a lot of these other orchestration systems as well that you may want to tie this into. We also have the ability to even do things like drill into the application servers themselves, understand what's going on with these app servers. In my first example I was showing here, I was showing that, bless you. I was showing you that these servers periodically have this massive spike and hey, what's going on, what's causing that? And we have the ability to drill down into that and understand what's going on. I can go look at my servers here. One of these guys has a lower health score, so let's go and explore it. And I can go and tell you that the CPU, memory, other resources on your application servers on the back end, all this information is being pulled and gleaned from vCenter. So we're taking this information from vCenter, pulling this in, and I can tell you that at its peak over the last 6 hours or so, I can tell you any particular time, but at its peak, the server's running at 80% CPU, whereas all the other servers in the pool are averaging about 40%, half as much. Same thing with memory. This one's running about 3 times more memory consumption than the other servers in the pool. So I may not be able to tell you what's going on this server, but I can tell you that this server is the cause of our problems, and we need to go and explore what's chewing up its resources every 2 hours. In this case, we have a log rotation because we don't have enough disk there. But I can pinpoint pretty quickly where you need to go and explore, what the problems may be, and say this is where you need to go and explore further. Let's go and see what's going on with this guy. So this is great because what you end up with in a typical environment is that the network guy, he's simply going to point the finger at the application. The app guy is pointing the finger at the network. In our case with the Mazzetti example, both were actually a problem. And so neither of them were able to solve the problem because they were both convinced that it's the other guy's fault. And now I can tell you, you're right, it is the other guy's fault and it's your fault. So having this level of information and insight and visibility is something that the industry has never really had before. You may have troubleshooting or visibility tools, but they're only available to the network guy, or the app guy has his own visibility tools, but the two can never see eye to eye because they're using completely different, separated, isolated worlds. So this gives you this ability to understand what's going on. If there's an issue, resolve it, troubleshoot it, scale out the infrastructure if necessary, if that's the application delivery, the load balancer, or even the servers on the back end. So if you have any questions, by all means, fire away, and somewhere between Melvin and I, we should be able to answer them. But thank you very much for your time.